Good morning, chemistry students. I got a couple of emails saying that some of you are a little frustrated with the single replacement reactions. And because I've heard it from a couple, I'm guessing there's probably a lot more of you that maybe are feeling that way. So I don't want you to be frustrated. So thank you for those of you who emailed me and let me know that, because I'm happy to kind of go through this again. And if we need to schedule a Zoom meeting and do this live at some point today, that would be totally fine. I know some of you that's not an option because of internet and whatever. So I do want to make this an instructional video. There were a couple of specific questions, I know, from Alex. Thanks for doing that, for being specific, so I kind of know where to start. All right, so quick review of the single replacement reaction. So this is, remember I said it's like, two people on a date and they bring their friend with, and by the end of the night, the friend has stole the other one's date. That's, I know, weird, but just kind of I think an analogy that sort of said, oh yeah, they switched partners and now a different one is single. So single replacement reaction, remember, because the next thing, yeah. So just remember, single replacement reaction, we are talking about something is singly by itself on this side, and then a different something is singly by itself on this side. And so you can see the compound has changed. So this, the nitrate that was with the copper, that nitrate is now with the zinc. So here's a couple of things that we have to understand about single replacement reactions. So zinc is a metal. I do have to know, and I think in the last video I ran out of time a little bit. So you will need your ion sheet, because you have to know how these are going to combine. So let's start with that. Grab your ion sheet. All right, so ion sheet, if I look up the charge of zinc on my ion sheet, I see we have a plus. This has a 2 plus or plus 2 charge. I don't care how you write it. A little bit tricky here. There's more than one form of copper, and this is this does get a little bit tricky, but I can figure out which copper it is based on this formula, because if I look up the nitrates, this NO3 is a -1, but I can see that it took 2 of these to cancel the charge of the copper, which means that this must be copper with a 2 plus charge. All right, so the cool thing about this is, so this copper is going to bump, or this zinc, sorry, is going to bump copper off of this compound. And since they're both +2, it does combine in exactly the same way. So that's, in a nutshell, that activity series. In order for this reaction to proceed, I do need to look at the activity series, which I know I showed you that the other day. Let me bring that up really quickly. And so here's that. We do need to use the activity series chart. So things that are most reactive are at the top. And if you work through that worksheet that I gave you with this, I think that really, really helps you just sort of use this and understand. And we know there was even a question about we call these a lot of times the coinage metals, because they're so non-reactive. So always remember that's why silver and gold and even copper are used to make coins, because they're really not reactive. It's also why we use copper for plumbing. Not very reactive. We used to use lead, but we know better than that now. That's also not very reactive with components that might be in the water. Anyway, so I had zinc replacing copper on that compound, because zinc is more reactive than copper. Okay, a couple of tips. Now that I'm looking at this worksheet, I actually feel kind of stupid, because of course you don't know the formulas to these acids, and I kind of suspect that maybe that's where some of the problem is. So let me give you those, because I think that will be helpful. I'm just going to write them in really quickly. All right, so let me give you these three, because I think I suspect that this is where some of our issue is. All right, so hydrochloric acid is HCl. Nitric acid is HNO3. So it's an acid made. So all acids start with hydrogen. And remember on our activity series that it tells us whether these are strong enough to replace the hydrogen in an acid. And if they're not, then we just write no reaction. So we're really trying to use that activity series to determine what the products are, and also whether a reaction would even occur with these products. All right, so let me just do one of the acid ones with you. Let me pick one that, let's just do, so I'm going to do number 6 with you as an example, because that's one that actually bromine is not a metal, right? So I want to talk about that one too, but let's just do, I don't know, let's pick number 8. So magnesium. So here's what I need to do. This is going to be messy because I'm writing with the mouse. So I know I have to look up the charge of magnesium. I need to know what the charge of that is. The symbol is Mg. If I look magnesium up, I know it's a 2+ charge, right? Hydrogen, I'm just going to sneak this in here. Hydrogen is always a +1 charge. That's been added to your ion sheet. And then nitrate, remember we're talking about hydrogen, and then we have nitrate, this whole one here. And this nitrate is a, well, that's hard to read. Let me go back to my black. Nitrate is a -1. And I actually would know that without looking this up, although feel free to use your ion chart. That's why you have it. But hydrogen is because this combined in a 1-to-1 ratio, one H and one of these NO3s. So if hydrogen's a +1, this must be a -1, right? Otherwise, it would have taken more than one of these or more than one of these. All right, so now I need to look up my activity chart. So let me bring that up. So my handy dandy activity chart says, hey, magnesium, there it is. Magnesium will replace hydrogen in an acid. So I know a reaction is going to occur here because it's saying, yeah, this actually will replace. So my magnesium is going to bump the hydrogen right off of there. And so my products for this, and when I write this out, I put the charges here, but my final equation should look like this. I'll show you in a minute. So I'm actually going to have hydrogen, and here's what you need to remember. Remember a long time ago when we said that some elements exist in the diatomic state when they're by themselves. Now when we're getting into balancing reactions, here's where, and you don't have to balance these, I don't care, but here's why you need to know that. So the horses need oats for clear brown eyes. Hydrogen is one of those. And then we have magnesium. I am writing with my mouse, so I think I have skills, but not so much. The Mg NO3, but I do know, so Mg, and I can use the crossover method. I'm just going to write it up here really quick. So remember, I'm combining magnesium with a +2 with nitrate. That's a -1, and NO3 is a 1- or -1 charge. So I'm going to use that crossover method, but I don't want it to look like I have 32, right? And this is 1, but we don't write the 1 in our final formula. So remember our methods. that we learned way back in Chapter 7. Please go back and review if you feel like you need to. But because magnesium is a +2, oh, I'm running off the edge of the paper. I'm sorry. This is a 2. If I didn't write these formulas correctly, I would never be able to balance this equation correctly. Okay? And that's important that we be able to do that. So now I want to, if this is my final answer, so to speak, I don't want to have those charges represented in here because that is not how we write a balanced equation. I don't want my weird little, even this I don't want, this I don't want. Okay, so this is my final answer. So magnesium, oops, I need a little plus in here, plus nitric acid, HNO3, yields in this reaction H2, and technically, remember we talked about these symbols. This is a gas. We put a little G, sorry, writing with my mouse. And then magnesium nitrate, and this would be in an aqueous solution. You don't have to know that right now, okay? But I'm just saying, remember we did talk about those. All right, so I hope that that clears up some of these. And so now you have to go back and say, okay, in sulfuric acid, is silver going to be reactive enough to bump the hydrogen off of the SO4 or sulfate ion? You need to go back and figure that out. Let's do this one really quickly, just because it's kind of a different one. It's not the metal that's switching places. Okay, so I've just written the formula really quickly. So sodium iodide, sodium is a +1, iodine is a -1, so those combine in a 1-to-1 ratio. Bromine is also a -1. So here's what I need to look at for this one. I need to say, hey, if this is this bromine, which is by itself, is this more reactive than iodine? So let's look at our activity series. Well, look at this. On the bottom where we have these halogens, bromine is more reactive than iodine. Remember, more reactive as you go up. It's less reactive as you go down. So iodine is kind of the least reactive of the halogens. Bromine is definitely more reactive. Chlorine is more reactive than that. And then fluorine is the most reactive of those halogens. So yeah, let's go back to our sheet. So sodium. So what we're saying is, yeah, bromine is totally going to kick iodine off of this compound. So my final, so these, I'm going to add these together. My final reaction then, sodium iodide plus bromine will yield sodium. Remember, the positive ion always goes first. Don't forget that. They're trying to trip you up by throwing a halogen one in here. So it's going to be sodium bromide and then iodine by itself. Oh, I forgot. So horses need oats for clear brown eyes. Don't forget your diatomic elements. Otherwise, again, it will never balance. So, so for my final answer here, let me go get my eraser. I do not want, I want that. I do not want, I don't need that arrow there. I don't need these underlines here either. Voila. So hopefully that helps. If you still are struggling with any part of this, please shoot me an email and say, let me know if there are specific ones, because that's super helpful so I know where to start, especially since I already explained the lesson but didn't do a great job. So there were just some things that I forgot. Obviously, if you were here in the classroom with me, you would have asked those questions and the whole class would have seen it right away. So we will bump. So please work on this today, and then I'll just bump the other one back a day. I did give Friday as kind of just a work day catch-up day. So good luck. And again, thanks for asking questions. It helps me be a better teacher for you. And specific questions are always great. Thanks, guys.